Hello viewers, you're welcome. So today we want to continue with our partial fraction. I want to treat the second example, or what I call the second set of the examples. Number two, second set. So we want to look at whenever the denominator of the partial fraction is a repeated factor. Let's say cx plus d squared. Now this is a factor squared. Now this is how we break it down into component partial fractions. That's how we break it. Every time it is of this form, then we can break it down of that form. You get it now. So if it is raised to the power 3, then we repeat in this order. Raised to the power 1, this raised to the power 2, and that raised to the power 3. This could be any number, EFG. Now I want to showcase with an example. Let's say we have this, then of course it could be of the form, if we have to take this, since this is squared, then it could be so and so on and so forth. So it could be, say, since it could be e raised to the power, okay, let's not make them sure. Okay, let's still use e. So it's raised to the power 3x plus 2. You get the point. Plus 4, I mean to say 4. Plus f is about 3x plus 4 all squared. So in this case now, of course, as we usually do, we multiply this throughout. If you multiply this into the whole of this, you would get 18x plus 20. If you multiply this again to the whole of, to this particularly, you will get e in brackets 3x plus 4. Now if you multiply this again to this, you just get f, because this is going to cancel out with this one multiplied. So that's what we would have. So opening up, it becomes 18x plus 20 equal to e, of course, this time this, that's e3x plus 4e or e4, anyone. Of course, usually we write numbers before alphabet, so usually, but to me it doesn't really matter. Okay, so that's how we do that. Then we comparing or equating coefficients. I'm saying equating or comparing coefficients. Comparing coefficients. So I would have 18x, or for the x's, let me put it this way, this and this, then put it their way. So I have ex or e3 or 3e, anyone. So for the x's, this equated to this, so x goes with x, or just x. So then for the one that doesn't have x, they are the constants, so we can say 20 equal this and that. So we say 4e plus f. Now if you look at this, this one would imply 18 equal 3e would imply that e is equal to 18 divided by 3, or all over 3 when we divide both sides. So that would give us, that would now give us 6. Now this one also would imply that since we have known e, then we're looking for f. So it would imply that f will be equal to 20 Now, making E subject, we'll subtract 4E from both sides. That will be 20 minus 4. Instead of writing E, since we know that E is 6, so we can just say 4 times 6. You get the point now. So that will give us, if you multiply, this is 24. 20 minus 24, that's negative 4. So that's all we have. So in other words, we're going to have that E is, so we're going to have that this is our expression. Therefore, we say this is our expression x plus 20 all over 3x plus 4 squared is equal to 6 over 3x plus 4 minus, since there's negative sign here, 4 over 3x plus 4. So squared, of course. So that's what we have in that case. Now the same thing. So I would like you to try this one. See the same principle. Try this. Okay. Try this. I want to see your answer. Try this. 10x minus 13 all over 2x minus 3 squared. Just give it a try. I would like to see it. I'm going to stop here, but let's just treat another example, say one more before we call it quit for today. Let's say we have this question. Say you have, let me say example 2, say 7 to 5x squared plus 3 x 35x minus 4 all over 5x plus 2 raised to the power 3. So our custom is, of course, it could be E or A. Okay, let me use A, B, C in this case. They are still the same thing. You can use any letter of your choice. 5x plus 2 plus 5x plus 2. Remember, the factors are increasing since this is raised by 3. So you keep doing it until you get raised to power. You raise it to the highest given power. Okay, so if you have that case, of course, our custom is you multiply this throughout the expression. So you're going to have 7x going to be 75x squared plus 35x minus 4 equal to A, of course, x plus 2 squared plus B 5x plus 2 plus C. So you now open up this. So continue is going to be equal to this. So A going to be 25x squared plus 20x plus 4 bracket closes plus B 5x plus 2 plus C. That would be 25ax squared plus 20ax plus 4a plus 5b x plus 2b plus c. So if you compare, I will say comparing, so the x squared is going to be 75 equal to 25a. For the x alone, the x's is going to be 35 equal to 20a, of course, x to x, and then x. 20a, then 5b. Then for the constant, say the -4, constant is going to be 4a plus 2b plus c. So for the first one, this would imply that a is equal to 75 over 25. That would be equal to 3. Then for the b, now if we make b subject of the formula, of course this will subtract both sides. That will be subtract 20a from both sides. That will be equal to 35 minus 20. Now instead of writing 20, we have known that a is 3, so we can just put it there. Then everything here will be divided by this 5. So we are going to have divided by 5. That will give us, of course, because 20 times this is 60, minus that's going to give us 25, and then negative 25, and that will be 5. Negative 25 divided by 5 is 5. Then this one, c, making c subject, we're going to see -4. Of course, -4 here is -4. This one moving across, that's 4a. Now a is, we know a to be 3, minus this one, b is -5. 2 times -5. At the end, we're going to see -6. -6 at the end of the day. So our answer is now, therefore, we have known a, b, c. So at the end of the day, therefore, we say that anytime you have 75x squared plus 35x minus 4 all over 5x plus 2 raised to the power 3, it must be 3 all over 5x plus this, then minus 5 all over 5x plus 2 squared minus 6 all over 5x plus 2 cubed. So this is our answer. Thank you. See you in the next video.